Here we have the infinite series of n dividing by the square root of n squared plus 4, and we want to show that this series diverges. So let a sub n be this, and then we want to find the limit of a sub n So to find this limit, what we can do is divide the top and the bottom by the square root of n squared. Since n approaches infinity, the square root of n will be just n. So note now if n were approaching if n were to approach negative infinity, then the square root of n squared would be negative n. And then here we can, since we have square root dividing by square root, then we can combine them. So this would be n squared dividing by n squared, and then plus 4 dividing by n squared. And this would be 1. And this would be 1. So as n approaches infinity, 4 over n squared will approach 0. So we get 1 plus 0, and then the square root of 1 is just 1. So this is equal to 1. And so we have shown that the limit of a sub n is equal to 1 as n approaches infinity. And therefore by nth term test for convergence, this series diverges because the limit of a sub n is not equal to 0. So right here we have shown that the limit of a sub n is not equal to 0. Therefore we can say that this series n divided by the square root of n squared plus 4 diverges.